All right, I have 12:30 Central Time on my clock, so I think we're going to go ahead and begin. I want to welcome everybody today. Our webinar is going to be Back to Basics on Endangered Species Conservation. I am Lene Jess, and I am the Working Group Liaison for the North Central IPM Center. And we are one of 4 regional IPM centers that are supported by USDA NIFA through the Crop Protection and Pest Management Regional Coordination Program. We have a mission to coordinate IPM across the region by sharing and promoting IPM research, extension, and teaching activities. If you have questions during the webinar, please put them in the Q&A box on your screen there, and then we will answer all of those at the end of the webinar. And today I want to welcome Adam Janke. He's an associate professor and wildlife extension specialist at Iowa State University. And again, his title is Back to Basics on Endangered Species Conservation. Kelsey will be putting some links into the chat as we go that Adam has provided about his talk. So welcome, Adam, and go ahead and begin.
Great. Thanks, Lene, and thanks, folks, for the opportunity to present on this topic today. Something that's certainly been in the conversation or been in the ether for a while. A lot of people are interested in this topic, and I'm excited to sort of offer my perspectives on the topic as we start to think about what endangered species conservation might look like on our farms and even in our forests and backyards and anywhere we're managing land. And so I am the wildlife extension specialist at Iowa State University, which means I have broad responsibilities in wildlife education. And I'm also a wildlife biologist and wildlife researcher. And what I bring, I think, to this presentation is just an experience with wildlife monitoring and wildlife conservation that will hopefully help people sort of step back from maybe what they've heard about endangered species policy and endangered species management and think about the basics as the title implies. So that's certainly my goal today. Look forward to sharing some remarks and then certainly answering questions that folks have at the end. Here's my outline for the presentation where I'm going. I want to first decide or define what we're talking about when we say endangered species. I think that's part of going back to basics on endangered species conservation, thinking about what we're working to do with endangered species conservation. The next is we're going to talk about the basics. We're going to do a wildlife conservation 101 class about the basics of the things that wildlife conservation professionals think about when it comes to conserving rare and declining populations of wildlife. And then finally, we're going to talk about some of the regulatory basics, the sort of rules surrounding endangered species. On my way, I would like to establish or just sort of transparently share with you my own logic that I applied in developing this presentation today. One, as the title implies, back to basics. I am going to go all the way back to some of the core fundamentals, even defining what we mean when we say endangered. That's, I think, an important thing to kind of make sure that we're all on the same footing. The next thing is just sort of my apology and disclaimer, as I am a vertebrate ecologist. You will see that I think primarily about things with spines. And then after that, I think about things in the animal part of the world. And though many endangered species policies apply to plants as well. So I'll make occasional references to plants, but I'm no botanist. And so you'll notice the bias in my presentation towards animals. And then I will also, because it's what I'm most familiar with, primarily feature Iowa examples. And then finally, and perhaps most importantly, I want to emphasize that I am an educator and a researcher, and I'm not necessarily a representative of the agency's tasked with managing endangered species in a regulatory context. So I'm going to do my best to talk about some of that stuff, but it's also not my world. And I think what I wanted to do in this presentation anyway was to step back away from that a little bit and talk about the fundamentals first. And that's what I think as a wildlife educator I can bring. So in that, I'm going to talk about principles primarily, not policy, though at the end we'll certainly visit some of this policy reality that applies to endangered species conservation. So back to the basics. Join me in a stuffy room filled with asbestos stuffed animal specimens in the basement of Science Hall 1 on the campus of Iowa State University. This is one of our teaching spaces that we don't use a ton because of the aforementioned asbestos, but I bet universities that you're familiar with or have attended or even natural history collections have collections like this one that I took a picture of. In these collections, we're reminded of the rich biological diversity that we have here in any place that we're working or globally. And in the back corner of our collection in the basement of that science building on Iowa State's campus are these specimens in that share taxonomic relations. The top two specimens are a bird called passenger pigeon, and the bottom one is a bird called the mourning dove. Now, the mourning dove, I suspect that every single person on this call, if you are indeed in Eastern North America, as I assume, is probably at least within a mile, probably within a couple of yards, a couple of 100 yards of the nearest mourning dove. It's one of the most ubiquitous birds that we have in North America. They're a game species. They're thriving here in our country. The other bird, those top two specimens, is called a passenger pigeon. And no one on this call and no one living today has ever interacted with a passenger pigeon because in 1914, the last of the species was driven to extinction. Historically, 200 years ago, 300, 400, 500 years ago, each of these birds would have been ubiquitous in Eastern North America. Passenger pigeons were described in early accounts of written histories of American history of blackening the sky in Eastern North America. They were so ubiquitous. But through unregulated exploitation and the destruction of their habitat, primarily oak forests of the eastern United States, that bird was driven entirely to extinction. And so those two specimens sitting together in that stuffy museum in the basement of Iowa State University Science Hall 1 remind us of the two poles that we're working on when we talk about wildlife conservation. That is a pole of species that are thriving, like the mourning dove, and unfortunately and dangerously, species that on occasion are driven entirely to extinction. And much of what wildlife conservation is about avoiding overstepping that line that leads to extinction that we can never recover. And so many species in the history of wildlife conservation in North America have threatened that line. Each one of these species on the slide within recent memory have been threatened with or endangered with extinction. And through the work of wildlife conservationists, including both sort of voluntary and regulatory interventions, each of these species today has been saved from extinction. And some of these species, like white-tailed deer, giant Canada geese, and wild turkey, you may be surprised to learn were even ever threatened with extinction. But they were. And so what I'm going to talk about today is how we keep animals on the left side of that dangerous line of extinction where the passenger pigeon today resides. And so what do we mean when we say endangered? Well, lots of different definitions on the topic have been written. I thought that I would actually go into a textbook and find some textbook definition of extinction or endangerment, but I can't say that I necessarily was successful with that. But this paper on the determinations of extinction had a statement, thus mechanisms underpinning ecological results such as the probability of extinction likely depend both on properties of species, such as the population growth rates and carrying capacity, competitive dominance, dispersal capacity, etc., and on characteristics of the environment with which individuals in the population interact, such as time and space variation and equable environments or productivity of the habitat. Lots of jargon there. That is to say that scientists have sort of understood or studied things that threaten species with extinction. And much of wildlife management is about describing those processes and trying to mitigate factors that threaten species with extinction. Other groups, including both in the public sphere and in the private sphere, have gone to lengths to try to categorize species and characterize their relative risk of extinction. And we'll come back to this list by the International Union for the Conservation of Nature in its respective categories a little bit later in the talk. But those categories provide sort of a nice glimpse of the road to extinction from, say, the mourning dove, which would fall in this green category of least concern. They are thriving in the landscape today, to extinction, where the passenger pigeon resides in the black, That road is paved by these different categories that IUCN uses in classifying species risks of becoming extinct. When they are evaluating a population's the degree to which a population is threatened with extinction, wildlife ecologists like me, people trained in my discipline, categorize populations in a few different ways to try to understand where they may fall with their risk of becoming extinct. And IUCN and other organizations classifying species as endangered or not use a couple of different rules. One of these rules is just the sheer abundance of a population. Just species rich or numerically abundant populations of species are less likely to go extinct because there's fewer catastrophic events that may have widespread negative impacts. So one category we use is the populations of least concern tend to be rather abundant, and the populations of critically endangered species tend to be quite rare or are often quite rare. But sometimes species like the passenger pigeon that was once very abundant, hyper abundant, can become extinct or threatened with extinction through changes in abundance. So another thing that we use to gauge how at risk a population is of becoming extinct is we monitor changes in abundance through time. And that's what's depicted with this slide. And then finally, we also monitor the changes in the geographic extent of a population. A population that is once abundant and has a wide geographic range that starts to trend towards extinction, trend towards being endangered with extinction, will demonstrate range contraction where it's taking up less area than it historically did. Each of these signs can be taken as an indication of a population's vulnerability to extinction, and that's what we use in categorizing species and then developing interventions that seek to reverse the threat of becoming extinct through endangered species or rare species management. And to understand how we manage populations and understand characteristics of populations, we have to understand this fundamental equation, which is Wildlife Conservation 101. We talk about the changes in abundance of a population, which would be N of T plus 1, the left-hand side of this equation. So the population size next year is the product or is the sum of the population size this year plus the births into that population minus the deaths from that population plus new immigrants into the population minus immigration, the individuals that leave. Now, when we talk about extinction, we're almost always talking about the entire population of a species. So those last two categories, I and E, species or individuals coming and going from a population, don't matter. And so understanding a population's demographics is built on an understanding of how the balance between births and deaths operate in that population. A growing population will see births or productivity exceeding deaths or mortality. A stable population will see balance in that. In a declining population, we'll see deaths exceeding productivity or deaths exceeding birth. And that's often what wildlife ecologists are looking to understand. To give you an example of what this looks like in real life, we can look at the bald eagle population trends in the United States. This is based on the North American, I guess all across North America. This is data based on the North American Breeding Bird Survey. And the y-axis is just an index of relative abundance of bald eagles through time. And what you can see is this increasing trend in bald eagle productivity. So that is a population where the equation is reflecting change, positive change in the population abundance through time, meaning births are exceeding deaths. And in this case, the history of the bald eagle population in North America and globally is that in 1972, a ban on the chemical DDT went into effect, and that facilitated a recovery of that population because productivity or births had been almost entirely suppressed in the DDT era, and the ban of DDT facilitated births to recover and thus the population to recover. So that's an example from the history of rare and declining wildlife population management that reminds us of how these scales work. DDT was pressing down on the birth side of the scale. And when we stopped pressing down on the birth side of the scale, we allowed for the population to recover. And so that, unfortunately, is sort of the simple model when a single factor is constraining a population. And we would call that a direct effect. When we reflect on how can we manage populations, rare and declining populations of wildlife, we want to think about what levers we could essentially be pulling. And in the case of DDT, that was a very clear direct constraint on the ratio of births and deaths in the population of bald eagles, peregrine falcons, other predatory birds. And once we pulled that lever, once we stopped that direct effect of a toxicant suppressing productivity in bald eagles, the populations recovered. There are rare instances where that can work for other rare and declining species, where we could perhaps constrain exploitation. Like, for example, I mentioned the passenger pigeon was probably driven to extinction from unregulated harvest, market hunting, basically. If we would have pulled the lever of unregulated exploitation, we might have been able to save passenger pigeons from extinction. There's other direct effects that suppress population growth, like incidental mortality, like, for example, through development in a specific area that perhaps harbors a large percentage of a population. Disease, like, for example, with what we're seeing today in bats in eastern North America and the detrimental or decimating effects of white nose syndrome, or predation in certain instances, especially the introduction of a novel predator. If we can manage those direct effects, we can help those populations recover. But a challenge is that it's often sort of indirect. It's not as simple as ban DDT and recover bald eagles. I mean, I know I'm not trying to oversimplify that, but that was sort of a one-to-one relationship back then. And oftentimes there's sort of more indirect effects. For example, constraints on a population's nutrition or nutritional plane, constraints on a population's ability to thermoregulate, a population's ability to reproduce, or their connection between subpopulations within a larger population of a species. And when we talk about managing indirect effects, and to a lesser extent also managing direct effects, what we're talking about is the management of a species habitat, the habitat that supports and allows a species to thrive. And so I want to briefly just define what we mean when we say habitat, because it's so central to the recovery of endangered wildlife populations. So habitat is the three things we all need to survive: food, water, and a roof over our head, or shelter. And then a fourth consideration for space, or the arrangement of these important elements on the landscape and a population's ability to connect. I'm going to examine each one of these just briefly, just so you know the variety of food, water, shelter, and space requirements among the variety of species. No one animal's habitat is the same as another. Water can come from surface sources, metabolic sources like from the diet. Factors like water quality or water quantity constrain a population's growth or reproduction. And water can also be a conduit for movement, of course, especially among aquatic organisms, many of which are threatened with extinction. Food can come in a variety of forms. Everything eats everything else. And so nectar, invertebrates, vertebrates like other wildlife, plants, vegetative material, and fruits of those plants can all comprise food for different species at different times in their life. Shelter comes in many forms, and when we think about rare and declining species conservation, we want to make sure they have shelter for reproduction, shelter for hibernation, shelter for migration, roosting, escape or safety, or thermal cover throughout the day as well. And then space is that fourth component that considers the arrangement of all those elements. I want to admire a couple of ways that wildlife ecologists talk about space for wildlife conservation. The first and most obvious one is just the proximity of those essential resources. If, for example, all the water were in the northeastern quadrant of Iowa, and all the food were in the northwestern quadrant of Iowa, and all of the shelter were across the southern half of Iowa, the only place there would be habitat for that hypothetical species is right where those three things meet. So we have to make sure that all of the things a species needs throughout its life are provided in an arrangement that they can get to. The other consideration that we talk about with space, and especially for rare and declining populations, is how connected they may be to other populations, for other sources, perhaps for genetic connectivity or dispersal or migration, other important life history events. Some species demonstrate a characteristic called area sensitivity, where they just need large patches of habitat, whereas others kind of get by on the margins or get by in small patches. So some species space requirements include a minimum area, often endangered species. And then finally, fragmentation is a factor in space related to area considerations as well. When we put all of this together, we have a species habitat that could potentially support their recovery. And then it gets even more complicated, because a species habitat may not be the same thing in the summertime as it is in the wintertime, as is the case for migratory animals like the Henslow sparrow that breed in the upper Midwest in winter on the Gulf Coast, or is the case for resident species that just spend their life in different areas, like the rusty patch bumblebee that spends its winters primarily in forests and its summers primarily in prairies, and needs habitat in both of those places to survive. What we get in the end is every species habitat is different. This is just a listing of rare species found in Iowa and all the places we may find them in a hypothetical landscape. And so to say we have endangered species habitat may not necessarily mean we have habitat for all of the endangered species that may occur in any given landscape. So it gets complicated when we think about the variety of species that we may be managing for. So how do we conserve endangered species? Just in review, we want to prevent or minimize direct mortality. We want to keep the death side of the equation low. We want to promote productivity by keeping the birth side of the equation high. And we want to connect populations to facilitate persistence, especially as they become more rare and may be at risk of becoming isolated and exposed to extreme events. So our lingering questions then for endangered species conservation is, who are we talking about? What are the endangered species? Where do we conserve endangered species? And who is responsible for endangered species conservation? And this is where I'm going to end the presentation and start to talk about some of the regulatory environment surrounding endangered species. So first, what species are endangered? I'll lead with a source of often confusion. This was a headline from 2022. Migratory monarch butterflies are now an endangered species. This hit a lot of headlines and caused a lot of people to think that things, especially in the regulatory environment, had changed. But in reality, this is just a decision by one body that assesses the status of a population. The International Union for Conservation of Nature. This is what I was exploring earlier in the talk. This is non-regulatory. It's done based on expert opinion. And although these categories are very useful, they don't necessarily come with any sort of formal protection. So that type of endangered species is worth considering and being aware of. But often when people are talking about endangered species, they're talking about them in more of a regulatory context, which comes to laws. And so first, most states, including Iowa, have laws protecting rare and declining species. This is Iowa's law, passed in 1975. And actually, if you were to study this law, you would find it's modeled after the federal legislation, which is what I'm sort of building towards. Just in passing, most states have some sort of endangered species legislation. They have variable regulatory teeth and processes. For example, in Iowa, there's not a lot of regulation that comes along with our endangered species legislation. And they're often focused on preventing extirpation and not necessarily extinction. For example, in Iowa, the red-shouldered hawk is listed as an endangered species, but that's ubiquitous in eastern North America, but it's just really rare here in Iowa. So an important distinction. This brings us finally to the Endangered Species Act of 1973, which is what most people think about when we say endangered species. And it is the act that has the most regulatory teeth. It was signed in 1973 by Richard Nixon. It is the Endangered Species Act legislation in the United States, and it's certainly the one that has the most constraints. It defines endangered species, and it also provides means and mechanisms for their conservation. So I'm going to spend basically the rest of the presentation today talking about the Endangered Species Act of 1973. I wanted to mention first, it's only 42 pages. Here's all 42 pages just for fun. I also have it printed off here. I've been studying it and preparing for this talk, and you could conceivably go find this legislation on your own and read the whole thing as well. And I'll show you some rather verbose slides in the next few minutes that have direct text, just because I think it's important to go to the fundamentals, right to the source. But let me make another comment. It's complicated. This is a book published, the Codex of the Endangered Species Act, the first 50 years. And you can see this is a few more than 42 pages of legislation. And this has all of the case law and controversy and lessons learned associated with the Endangered Species Act in its first 50 years, which just were celebrated last year. And I also reference that in today's presentation as well. So although it's only 42 pages, it is a relatively complicated and often controversial piece of legislation. Among other things, offers definitions of what an endangered species is, which, recall, we asked that question at the beginning of our talk. It defines an endangered species as any species which is in danger of extinction throughout all or a significant portion of its range. Well, and we'll leave it at that, with some exceptions for pests. It also defines threatened, and so we'll often talk about T&E, threatened and endangered species. And then there is controversy and discussion about what even constitutes a species, and that's also defined in the law. It provides in Section 4, which is one of 18 sections in the law, a means for determining the threatened or endangered nature of any one species found in the United States. And importantly, it offers a lot of different reasons for listing a species as threatened or endangered. That can include destruction, modification, or curtailment of its habitat or range, overutilization, like exploitation, disease or predation, inadequacy of existing regulatory mechanisms, like by a state or a landowner, and other natural or man-made factors. And the law emphasizes a prohibition on take, or the direct mortality among endangered species. And the term take is defined as harass, harm, pursue, hunt, shoot, wound, kill, trap, capture, or collect, or attempt to engage in any such conduct. So it has a very broad definition of what constitutes take, and that's reflected in much of the implementation of the ESA. There's a process for listing species that you could learn more about from U.S. Fish and Wildlife Service resources. It's depicted here, but I just want to mention that this process is transparent and has a number of different opportunities for public input. In the North Central region IPM states, there are 88 species listed as either threatened or endangered on the Endangered Species Act. That's based on a summary of unique species found indicated to occur in each state based on U.S. Fish and Wildlife Service records. You can find all that information on U.S. Fish and Wildlife Service web pages, but I want to just show you what your state may look like here. And then here I want to show you just what some of these species may look like. And I have mentioned a few examples, and I'll continue to mention a few examples as we go. The next question for us to entertain is, where do we conserve endangered species? And the Endangered Species Act applies to both private and public lands on their specific prohibition on take. So everywhere an endangered species occurs, the Endangered Species Act could conceivably apply. The Act also authorizes the Fish and Wildlife Service to acquire land for the management of threatened and endangered species. So some Endangered Species Act or Endangered Species Conservation occurs on public land in that way. And then it also authorizes the designation of critical habitat for an endangered species population, which is defined in Section 4, and or authorized in Section 4 and defined in Section 3 as written here, and you can go read that out of the legislation yourself. But what's most important to understand about critical habitat designations is that it applies only to federal agency actions or federally funded or permitted activities that occur on the designated species-specific critical habitat. Here's a map of all the critical habitat designated in Iowa. There's only 2 species that of the 19 listed species that occur in Iowa, there's only 2 that have critical habitat designated, the Powesheik skipperling and the Topeka shiner. And here's just an example. This is Greene County, Iowa. You can see the Topeka shiner's critical habitat is the rivers that in the watersheds where they're found. And then the Powesheik skipperling critical habitat, for example, in Dickinson County, are public properties where there were historical records. This is what the critical habitat map for the North Central IPM region looks like, shown here in red. And this is the sort of summation. There's 21% of all the listed species in the region have critical habitat designated, and it takes up 3.5% of the land area of these 12 states. So just for your records. And then I should mention that all species habitat is critical when it comes to rare and declining species, but not all endangered species habitat is designated as critical habitat under the law. That's a common source of confusion. Finally, when we talk about where should we do Endangered Species Act conservation or endangered species conservation, I want to emphasize that it's critical that we do this on public and private lands. And this is a research study that established that demonstrated across the United States, a large proportion of endangered species ranges overlap privately owned lands. Finally, who is responsible for conserving endangered species? Well, first, the regulatory authority of the Act for all inland wildlife falls to the U.S. Fish and Wildlife Service. There are legal penalties that apply to everyone. Anyone that takes an Endangered Species Act could be committing a federal violation of the law. So everyone would be responsible in that way. The Endangered Species Act requires that the Fish and Wildlife Service collaborate with states. So state wildlife resource agencies like the Department of Natural Resources are critical partners in that regard. And there's critical expectations for collaboration across federal agencies. And this is the last and most important consideration, especially amid modern discussions about ESA implementation, is this important nexus between the U.S. Fish and Wildlife Service and other federal agencies for Endangered Species Act implementation as specified in Section 7 of the law. So one kind of interesting and cool ripped from the headlines example of this is the DOT was building an interstate bridge across the Iowa-Illinois border. And because the DOT is a federal agency, they could not violate or they couldn't impact critical habitat without ameliorating those effects or take endangered species. And so the DOT had to collaborate in consultation with the Fish and Wildlife Service, and they moved a bunch of mussels in the Mississippi River to avoid detrimental impacts of that bridge construction. That's one cool Section 7 example. Another Section 7 example that kind of brings us to today's modern conversations is about herbicide restrictions. EPA, of course, is the regulating body for pesticides, and the U.S. Fish and Wildlife Service is the regulatory body for endangered species. And Section 7 says that the EPA can't do anything that encumbers on Endangered Species Act policy. And that's why it is that the EPA and the Fish and Wildlife Service are now collaborating on the herbicide and eventually pesticides, generally rodenticides and insecticide policy on labels. So that all comes from Section 7. Here's what Section 7 looks like. And you could, of course, read this from the legislation yourself. But that's why we have federal collaboration for the policy. So in review, how do we conserve endangered species? You see that the Endangered Species Act is putting into practice these things like not killing endangered species, promoting productivity, and protecting their critical habitat right in that piece of legislation. And we answered these questions about what species are endangered, how do we conserve them, and who is responsible for it. So my final thoughts are, on our way towards preventing extinction, we should remember that as extinction looms, the stakes become really high. To go all the way back to the beginning of my presentation, the threat of extinction among passenger pigeons wasn't being considered in the early 1900s, and we went over that precipice and drove that species to extinction. Today, we have regulatory mechanisms in place to try, to the best of our ability, to not allow that to happen again. And as we get closer to extinction, the regulatory burden increases. And that's what's depicted on this gradient on this slide. But we should remember that listing is a last resort. We don't want to list species as being threatened or endangered with extinction. We want instead to try to get as many species of plants and animals that we have here in the United States into that thriving category, doing well in the landscapes in which we live, work, and play. And so that's the final thing that I want to say about endangered species conservation, is that it's everybody's role to play in preventing species from going closer and closer to this extinction threshold. And that's where we see a lot of work within the Fish and Wildlife Service, within state wildlife resource agencies, and non-governmental organizations doing wildlife conservation, trying to help people do collaborative, preemptive conservation that prevents species listing or prevents species from becoming more rare or endangered. And you can learn more about that through, for example, visiting this website called Conservation Without Conflict. Lots of people talking about a model of collaborative conservation that prevents listings altogether. And you can see really cool examples of that playing out today, for example, with the monarch butterfly in the throughout the United States and the sage-grouse in the western United States, of collaborative, preemptive, pre-listing conservation that really is the future. So everything we do on a farm, from integrated pest management, tillage, to everything else, has impacts on wildlife and wildlife populations. And a collaborative model of wildlife conservation would look for more opportunities to do right by wildlife on every farm and at every house, to try to prevent species from becoming threatened or endangered with extinction, and also in doing so avoid some of the regulatory burdens imposed by those increasing stakes of species approaching extinction. So with that, thank you for the opportunity to present on this. Look forward to entertaining questions from the group, and my contact information is on there as well if you have any questions, comments, or suggestions. Thank you for your time.
All right. Thank you so much, Adam. We appreciate that. It was very interesting. I have a question. So can you give any examples of things that farmers in Iowa might be doing to help conserve, like monarchs or other rare species?
Yeah, absolutely. I mean, the monarch story is just a really cool one. A lot of people have relationships with monarchs and are finding creative ways to conserve monarchs on the edges of their farms. I have like 4 rules for wildlife conservation on farms, and they are, find opportunity areas on the farm to create new habitat. For a species like monarch that can disperse and find habitat patches in that, are pretty simple, like milkweeds plus flowers, and you've got monarchs. You could do this in a barn lot. I know people that have converted what was once mowed turf grass into prairie, and monarchs are thriving in their barn lots. You can do this on the edges of fields, like flood-prone areas or compacted areas of the field. Take those out of cultivation where you're probably not making a profit anyway, and put them into diverse native perennial vegetation that monarchs need. You can also improve existing natural areas, like the edges of forests, or even prairies or CRP fields, or something that you already have in your portfolio. You could look for ways to diversify those, or manage manage invasive species to try to promote wildlife diversity in those areas as well. So those are kind of the cool examples. I love it when people are creatively reimagining the uses of their fields for creating wildlife habitat.
Great. And just remind everybody, if you have any questions, please put them in the Q&A box. But I have another question. So what about hunting or other forms of mortality for rare species. You talked about the sage grouse. Are they still being hunted even though they're
Yeah,
considered for listing?
yeah. So, yes, sage grouse are still being hunted in some states, definitely not all states. The harvest is relatively limited, and this is a complication. Now, listing on the Endangered Species Act would be an end to hunting, I think. I'm almost certain that they wouldn't permit take of sage grouse if they became listed. Um, Today, what we say is that there are compensatory mechanisms in place. So just because an organism is, for example, dying, doesn't mean that that death is constraining the population. And so what that means is that the removal of a few individuals during a hunting season may allow for more individuals to survive limited food availability during the winter. We call that compensation. And we know that that's playing out. Now, as species get rarer and rarer, the contribution of each individual organism in the population becomes more consequential. And so, of course, we would want to do everything we can to prevent the death of a single California condor, where there's, a really small number of California condors left in the world. But for more abundant species like monarchs and sage grouse, sometimes things like harvest are fine, or mortality associated with land management. And the Endangered Species Act does have exemptions that could allow for the incidental take, for example, of a few, if monarchs were listed, say monarch larvae, to do a prescribed burn that would make that prairie better for monarch larvae for years to come. And so there's those sort of exemptions in place to say, understanding of the species biology, understanding of their habitat means that we need to use a metaphor, crack a few eggs to make an omelet. It could be that we need to do some active management that has short-term negative impacts on a population to gain long-term positive impacts on a population. And that's another thing that wildlife biologists are good at sort of penciling out, is sort of understanding where the sources of demographic constraints may occur in a population and focusing on the right limiting factors like habitat quality, and not being sort of distracted by other factors like death from prescribed fire or something like that.
Okay, great. Another question. Have you or your colleagues had a lot of inquiries about the EPA's work on the ESA regulations like Bulletin's Life 2? If yes, how do you respond as an extension worker at a university?
Well, absolutely. And my response is like this talk, which is trying to get people on the same page, at least to understand what's going on and why. So, for example, like just a reminder, the whole reason that there is this herbicide strategy coming along is Section 7 of the Endangered Species Act, which you could go read for yourself and understand what's written in law and the sort of law of the land, and why it is that the actions of one federal agency, in this case the EPA, need to comply with the mandates of another federal agency, the U.S. Fish and Wildlife Service. And so that would be part of my education or messaging on that. Yes, things are changing as it relates to pesticide labels and endangered species conservation, but the spirit of those changes are to prevent species conservation, which we know from sort of public discourse and, I don't know, my own personal opinion, is really important to prevent species extinction. So we might have to change the way we operate in certain places with certain products to prevent additional species from becoming extinct. And I think we extension educators have a lot of work to do to help people understand how to make those transitions in a way that still leaves their farm profitable and also conserves wildlife population on or around the farm. So, and lots of really smart people working on that. That's that whole collaborative conservation model that I mentioned.
All right. We have another question. What are we generally seeing in terms of the off-farm effects on habitat and species due to the on-farm tile drainage?
Yeah. So what I would say, like off-farm effects would have to do with water quality. And so like on-farm effects would be the drainage would facilitate land conversion, like conversion of wetlands or conversion of like wet, like meadows, grasslands, prairies into annual agriculture. So that would be like the on-farm effects of tile drainage. The downstream effects of tile drainage is that a lot of nutrients can move in water, namely nitrogen is primarily what we worry about. Well, and phosphorus in this larger region. Nitrogen and phosphorus move in tile drainage, get into surface waters, and then in surface waters can sort of throw off the balance of the ecosystem and lead to things like harmful algal blooms or drinking water impairments and the like. And so, yeah, water quality is certainly a factor in many of these species population declines, including species that would be listed as federally threatened or endangered. One thing that's just really remarkable when you analyze these data, and actually I could just go back to that slide. Look at the number of clams, which would be like mussels. Clams is just kind of like the weird way they classify them. But look at the number of freshwater mussels listed on the TNA list. That is a reflection of the extent of hydrologic modifications that we have done to surface waters, namely rivers and streams, and the challenges that we have with water quality and other like sort of structural changes to waterways that make aquatic ecosystem conservation a challenge. So that's why it is that we talk to people about on-farm practices to reduce nutrient loss and to try to improve surface waters downstream.
All right, thank you. I think that's all we have for questions. So again, I want to thank you, Adam, for taking the time to talk to us about the endangered species conservation. And I want to remind everybody that our next Pests in Progress webinar will be on Wednesday, July 17th at 12:30 Central, 1:30 Eastern, and it will be using social network analysis to understand pest management practices of vegetable growers in the Great Lakes region of North America. And so thanks everybody for joining us, and thank you again, Adam, and we'll see you next month.